In this video, we will go over integrals that are paired with powers of sine and cosine and pairs of secant and tangent, both even and odd degree power. So this is Calculus 2, Advanced Trigonometric Integration, powers of sine, cosine, secant, and tangent. So what happens when you have an integral of both sine and cosine, or both an integral of both secant and tangent? What would be the correct u substitution? So that's what we're going to go over today. There's a little trick we could use to figure out the correct u substitution. But before we move on, let's review some trig integrals. So we need to write this down. Go ahead. So the integral of cosine of a of x d of x is 1 over sine of ax plus c. The integral of secant square of ax dx is 1 over a tan of ax plus c. The integral of secant ax times tan of ax is 1 over a secant of ax plus c. The integral of tan of ax dx is negative 1 over a ln of absolute value of cosine of ax plus c, or 1 over a ln of absolute value secant of ax, absolute value plus c. Okay, the integral of cotan a of x d of x is the integral of cosine ax over sin of ax dx equals 1 over a ln of absolute value of sin of ax, absolute value plus c. The integral of secant of a of x d of x equals the integral of secant of a of x is going to equal to 1 over a ln of absolute value secant of ax plus tan of ax, absolute value plus c, right? Okay. So yeah, once you got that down, and then the integral of secant of ax dx is negative 1 over a cosine of ax plus c. And the integral of cosecant squared of ax dx equals to negative 1 over a cotan of ax plus c. And then the integral of cosecant of a of x times cotan of ax of d of x is equal to negative 1 over a cosecant of ax plus c. So you need to write down which rules. That's fine. And then let's review of trigonometric identities. So you've seen this before. Pythagorean identities: sine square x plus cosine square theta plus cosine square theta equals 1. If you solve for sine square theta, it would be equal to 1 minus cosine square theta. If you solve for cosine square theta, it's equal to 1 minus sine square theta. And then tan square theta plus 1 is equal to secant square theta. And then tan square theta is equal to secant square theta minus 1. Let's review some half-angle identities, odds and even identities. So sine square theta is equal to 1/2 minus 1/2 cosine of 2 theta. Cosine square theta is equal to 1/2 plus 1/2 cosine of 2 theta. Sine of parentheses negative theta is the same thing as negative sine of theta. And then cosine of negative theta is the same thing as positive cosine theta. Okay, now you know reviewed some identities. Now let's go over integrals involving powers of sine and cosine. So let's say you had a problem where you have a sine, an integral with a sine and a cosine, right? And you have different degrees. The rule states if sine is odd, so if your degree for your sine is odd, you're going to let u equals cosine of x and convert all the remaining factors of using your identity sine square x equals 1 minus cosine square x. If your cosine is odd, let u equals sine of x and convert all the remaining factors of cosine using cosine square x equals to 1 minus sine square of x, right? There's a little riddle. I don't know if this will help, but OSUC, it means if your odd is sine, your u substitution will be cosine. And you can use the riddle OCUS, meaning if your odd is if you have an odd cosine, your u sub would be sine. You're probably thinking, what if both were even? So we'll go over that rule too when both the degrees are even. But right now, this is when sine is odd and cosine is odd. Okay. So if you need to write that down, go ahead. I don't know. Yeah, I don't know if this riddle helps Osaka. Um, and then what happens when you both have an integral of secant and secant and tan? So if your tangent is odd, you're going to let u equal secant of x and save one secant. If secant is even, you're going to let u equals tan of x and save one secant square of x and convert the remaining factors to tangents using the identity secant square of x equals 1 plus tan square of x. And just like the sine and cosine, there is a riddle to remember this. There's something called O-test. So if you have an odd tangent, your u so is secant. And then you have this E set. If you have an even secant, even secant, your u substitution would be tangent. If both powers of sine and cosine are odd, use OCUS. Okay, so if both powers of sine and cosine are odd, you're going to use OCUS. If both powers of sine and cosine are even, what you're going to do is reduce the powers using half angle identities to convert the integrand to odd powers of cosine and then use OCUS. I know that's a lot to remember. If secant is odd and tangent is even, reduce the powers of secant using secant square of x equals 1 plus tan square of x. Okay, let's use those rules to do example one. So yeah, let's do example one. Example one says, take the integral of sin fifth x, or sin to the power 5x, times cosine square of x dx. Okay, so we're dealing with sine and cosine, and what do we know? We know that the sine is odd. So if their sine is odd, you're going to use u equals cosine of x. Or in our case, you're going to use OSUC, right? If your sine is, if you have our sine is definitely odd, power 5, your u substitution is going to be cosine, OSUC, right? And then you got to take the derivative of u. What's the derivative of cosine? Negative sine of x dx. And then what we have to do is, so let's do it. And then wait, if we're going to use OSUC, that means we're going to replace the remaining sine square x with 1 minus cosine square of x. And then you're going to replace sin 5 of x. Wait, so you understand that, okay, so if sine is odd, your u is going to be cosine of x. How does this all work? Okay, so sin is odd, right? I mean, the sine has a power 5, and sin of 5x could be expressed as sine square of x times sine square of x times sine of x. Okay, let's rewrite that. I mean, yeah, we're gonna see why did I write sin of 5 of x in terms of sine square x, sine square x times sine of x? Well, according to the rule, we have to use our identity sine square of x, right? Because sine is odd. So let's rewrite that. So I'm just rewriting sin of 5x as sine square of x times sine square of x times sine of x. And then we still have this cosine of x raised to the second power dx. And then we're going to use our identity. We're still going to use u as a cosine of x. Yeah, so our u, we said u is going to be cosine of x, so this is going to be u squared. Because yeah, u is cosine square of x, and then we have sine square of x, and then I think what we have to do is get rid of this minus because we'll have this sine of x, this extra sine of x and d of x. So let's get rid of that minus by multiplying both sides by negative. I think that's much better. Okay. Then what we're going to do is replace we're going to replace the sine square of x with 1 minus cosine square of x. So you have sine square of x, replace that with 1 minus cosine square of x. And then we said that u was cosine of x, so cosine of x to the second power is the same thing as u squared. And then you have this extra sine of x and d of x, which we said that sine of x of d of x is equal to negative 1 du. So you're going to replace the sine of x dx with negative du. Okay. Anything we can do? Yes. This invisible negative 1 is a constant, so you could just put that in front. And then we have this u squared here, and then you have this du. Okay, looking much better now. Let's clean this up a bit. Right here, 1 minus cosine square x minus times 1 minus cosine square x. You can rewrite that. That's the same thing as, because they're practically the same thing. You can rewrite that as 1 minus cosine square of x squared. And then you have this u squared du. We said that our u was cosine of x. So what I'm going to do next is replace my cosine of x with u. So it's 1 minus u squared of x. Oops, no. Yeah. I'm just replacing my cosine of x with u. So there's 2 here, so that's why I said u squared. And then you have a square here, and then you have this extra u squared du. Okay, then I would just kind of like FOIL this out. What is 1 minus u squared? That's the same thing as 1 minus u squared times 1 minus u squared. If you FOIL that out, that should be 1 squared minus 2u squared plus u squared e to the 4th. Don't forget I still had this extra minus. And then FOIL out this u, so this is going to be u squared minus 2u, u squared times negative 2u squared is negative 2u to the fourth plus u6 du. So what's the integral of this? The integral of u squared is 1/3 u cubed. The integral of negative 2u fourth is negative 2u5 over 5. The integral of u6 is 1/7 u to the seventh. Then we still have this minus 1. You must FOIL that out, so that's going to be negative 1/3 u cubed. So you could put the u on the numerator or you could put it on the center. It's entirely up to you, but do not put it in the bottom. I'll just put it on the u to make it easier. Oh wait, negative times negative is now going to be a positive. Okay, and then don't forget we have no boundaries, so it's a plus c. And then what you could do is last step is replace. We said that our u was cosine of x, so you may replace your u with cosine of x. So it's negative 1 cosine of cube of x over 3. So like I said, you can rewrite cosine cube of x either on the numerator or in the center. Okay, that is your final answer. Okay, good. Let's move on to the next one. So we have the integral of sin 6x times cosine q of x d of x. So what do we know? Our sin is even and our cosine is odd. So since cosine is odd, you're going to use ocus. So if that's the case, that means our u is going to have to be sine of x. And then you're going to use the remainder of the cosine. You're going to use, if you have cosine square of x, you're going to replace that with 1 minus sine square of x, right? Okay, let's do that. So we have u equals sine of x. So you have, so I'm going to rewrite sine of 6x as sin of x to the 6th power. I'll replace that with u. And then we have this cosine cube of x. So cosine of cube of x could be expressed as cosine square of x times cosine of x. So yeah, and then we're going to just replace cosine square of x with 1 minus sine square of x. Okay. And then plug in our u. So our u was sine of x. So this is going to be u to the 6th. And replace one of our cosine square of x with 1 minus sine square of x. Wait, so if our u is sine of x, my du is positive cosine of x d of x. Okay, so yes. Wait, so I replace my sine of x with u to the 6th because our u is the sine of x. I replace my cosine square of x with 1 minus sine square of x. And then we have this extra cosine of x dx, which comes out nicely as du. So you're going to replace this with du. Good. And then what shall we do next? We said that our u was sine of x. So wherever you see a sine of x, we replace that with u. So it's 1 minus sine of x squared is the same thing as u squared because our u is sine of x, right? Du. And then go ahead and FOIL that out. So that would be u6 minus u8 du. And take the integral of each term. So what's the integral of u to the 6th? It is 1/7 u to the 7th minus 1/9 u to the 9th plus c. And then the last step is replace my u with sine of x. So it's going to be 1/7. Let's see. Okay. Okay, let's move on to the next one. Let's do example 3. So we have sin q of x times cosine fifth of x d of x. Oh no, what do you see? You don't see an odd. They're both odd, right? I mean, yeah, both degrees are odd. So when you have a case where you have a sine and a cosine and both the degrees are odd, you still got to use ocus. Use ocus. So your u substitution would be sine. Okay. So when you have a sine, an integral of sine and cosine, and they're both odd degrees, you're going to use ocus, meaning your u substitution would be sine. So du would be positive cosine of x d of x. And then use your remainder of cosine square of x is equal to 1 minus sine square of x. Okay. So we have a sine cube x, and if our u is sine of x, that's the same thing as a u cubed. And then cosine 5 of x, be careful, that could be expressed as cosine square of x times cosine square of x times an extra cosine of x. So we don't have to worry about this extra cosine of x, that's because we can replace that with du. But we do have to worry about this cosine square of x times cosine square x. So we know that cosine square of x is 1 minus sine square of x. So it's going to be 1 minus sine square of x times 1 minus sine square of x. And then we have this extra cosine of x, right? And then we can replace, we have this extra cosine of x and dx, right? This dx hasn't gone away. we're going to replace that with du. Okay. And then what you're going to do, since we use our u as sine of x, just wherever you see a sine of x, replace that with u. So you have u cubed, 1 minus sine square of x is the same thing as u square, 1 minus u square du. Clean this up a bit. This is going to be u cubed. We have a 1 minus u squared times a 1 minus u squared. It's basically itself, so that could be expressed as 1 minus u squared to the second power du. And then kind of clean that up. What's 1 minus u squared to the second power? That's the same thing as 1 minus 2 times ab, so that's negative 2u squared plus u to the fourth. Okay, so that's going to be simplified as 1 minus 2u squared plus u to the fourth du. Boil out this u cubed, so this is going to be u cubed minus 2u, what's u cubed times u2, that's u5, plus u to that 4, 5, 6, 7 du. And then go ahead and just take the integral of each term. So what's the integral of u cubed? That would be 1 4 u to the 4th minus what's the integral of 2u5? That's the same thing as negative 2u6 over 6 plus what's the integral of u7? That's the same thing as u8 over 8 and then plus c. Let's see. So if our u is there anything I can do? Yes, I can reduce this 2 and this 6. This is 1 and this is 3. So it's going to be 1/4 and then replace my u with sine. So that would be sine 4th x minus 1 over 3. And then this is a u6, so that's going to be sin of 6x plus 1 over 8. And then this is going to be sin of 8x plus c. Right, not too bad. If you just follow the rules, you'll be fine. Okay, let's move on to the next one. Oops, not example 5, example 4. I skipped it. Okay. Example 4 says we have example 4 says we have sine square of x times cosine square of x or dx. So, oh no. We both have an integral of sine and cosine, but one is not odd and one is not even. They're both even. So yeah, both degrees are even. So what do we do when you have an integral of sine and cosine when both the degrees are even? The other problem was when both the degrees are odd. So what happens when they're both even and you have a sine and cosine? You're going to use half angle identities. So if you recall, we have two half-angle identities. We have sine square of x equals to 1/2 minus 1/2 cosine of 2x. And then you have cosine square of x equals to 1/2 plus 1/2 cosine 2x, right? So that's what we're going to use. So what we're going to do is replace the sin square of x with 1/2 minus 1/2 cosine of 2x, and then we're going to replace cosine square x with 1/2 plus 1/2 cosine of 2x. That's exactly what we're going to do. And what we're going to do is FOIL this out a bit. So there's no shortcut. You got to just FOIL it out one by one and just be careful. So I did the work, so you don't have to. So when you FOIL that out, that's going to give you 1/4 plus 1/4. Okay. And what can we do here? So when you FOIL it out, is there anything that cancels? Yes, this and this. So now you're left with okay. And then is there another? So when we FOIL, when clean that up, this is what we get. And I see that we have a cosine square of 2x. That's also an identity right here. Cosine square of 2x is equal to 1/2 plus 1/2 cosine of 4x. So it's going to be 1/4 minus 1/4 of 1/2 plus 1/2 cosine of 4x dx. And then if you FOIL this 1/4, you're going to get let's see, is there anything we can do? Yes, we can simplify this 1/4 and this negative 1/8. Uh, so LCD would be 8, so this would be 1/8. So when you simplify 1/4 minus 1/8, that is 1/8 minus 1/8 of cosine of 4x dx. What is the integral of 1/8 is 1/8 x. What's the integral of negative 1/8 cosine of 4x? Well, negative 1/8 is a constant, so take that out. So what's the integral of cosine of 4 of x? It is sin of 4 of x over the derivative of 4 of x, which is 4. And then plus c. When you clean that up, that's going to be 1/8x minus 1/32 sin of 4x c. Oops. Let's move on to example 5. Example 5 says we have the integral of secant 9x times tan of 5x d of x. So now we're dealing with secant and tangent. So what do we know? We have an odd tangent. So according to the rules, if you have an odd tangent, you're going to use the riddle otus. Uh, it just means odd tangent. That means you're going to use u sub secant. Okay. So if that's true, u equals secant of x, my du. What's the derivative of secant of x? It is secant of x times tan of x, d of x. And then we might have to use this identity because we have tan fifth. So we're going to use the identity tan square of x equals secant square of x minus 1. Okay, so we're going to use u as secant of x, and du would be secant of x tan of x. So what do we know? So I'm going to rewrite secant of 9 of x as secant of x times secant of 8x times secant of x, right? And you'll see why I did that. And then I'm going to rewrite tan of 5x as the same thing as tan of x times tan of 4x dx. Okay, you'll see, okay, since we use our u is going to be secant of x, where's my secant of x? My du would be, so here we're going to replace this secant of x with u, and then we have a when we take the derivative of that, we get secant of x tan of x. Oh, right, so wait, actually, secant of 8x, that's going to be like u to the 8th. And then we have this extra when we take the derivative of that, we have an extra secant of x d of x. So you're going to replace secant of x, tan of x, and then this d of x with regular du. And then what we're going to do is we have this remainder tan fourth x. We said that we're going to use tan fourth x is the same thing as tan square of x times tan square of x, right? And then what we'll do is replace tan square of x with secant square of x. Okay, so I'm going to replace this tan 4 of x as secant square of x minus 1 times secant square of x minus 1. Okay. And then is there anything else we could do? Yes. Secant square of x minus 1 times secant square of x minus 1 is the same thing as secant square of x minus 1 times, or to the second power. And then you have this du. Uh-oh. It looks like we're going to have to do some kind of double substitution. Okay. So it's going to be u to the 8th. And then we said that our u was going to be, our u was secant of x. So u is secant of x. So you're going to replace this with u squared. Minus 1, and then to the second power du. U squared minus 1 squared is what? U to the 4th minus 2u squared plus 1. U8 times U4 is U minus 2U10 plus U to the 8th U. U to the 12th is the same thing as 113. So now we can take the integral. U to the 12th is the same thing as 113. U to the 13 minus the integral of negative 2U10 is negative 2U to the 11th over 11. The integral of U to the 8th is U to the 9th over 9 plus C. Then the last step is replace your U with secant of x. So it's going to be 1 secant cube of x. I mean secant 13 of x over 13 minus 2 secant of 11x over 11 plus secant of 9x 9 plus c. I think we should stop here because if we continue the video, it would be more than an hour. So I'm going to stop here on example 6. So there will be a part 2.